Hi, this is just Mr. Carnstead. You're probably confused as to why you just see me on this video, but Mr. Harkins is still very sick. I am actually getting quite sick, and we all can't meet up to do this video, and I'm the guy that has the equipment, so I'm making this video by myself. So here we go. Today we're going to talk about resources and reserves. So these words revolve around the idea that we have a lot of stuff on our planet that we try really hard to take it out from our planet and use it for any sort of thing. Like we use oil to fuel our cars. We mine gold because I guess it looks good and people like having it. Um, well, the word resources refers to the total amount of these potentially valuable materials that are out there, whether they have a use or we just think they look pretty, like diamonds, I mean, whatever. Now, reserves are the portion of that resource that can actually be mined uh, economically, as we say. And what that means is you can do it and you can still turn a profit. You're not spending ridiculous amounts of money on mining this stuff to the point where you won't actually turn a profit. So it has to be worth someone's time and money to actually get reserves or to be able to get reserves. Um, so we have way more resources than reserves out there. That's because reserves is just a little portion of that word resources. Um, a reserve is usually a large concentration in one location. So, like an example is, even with gold, um, all the gold in the world is not evenly distributed throughout the world. It's randomly distributed. Um, it's very famous back in 1849. Um, they found gold out in California, and people went out there like crazy to find that gold. The reason they all went out there is because that was one of those random concentrated areas of gold that was out there. Um, if you had resources evenly spread throughout the world, that whole gold rush would never happen. Nowadays, there's a lot of gold mining happening um, in Africa, I know, a few other places in the world, but really not in the United States. Um, so anyway, there are certain resources that we have found these little deposits that are randomly distributed, and they may soon be out unless we locate another deposit out there. This tends to make things increase in value as supply and demand. Um, so we're going to start categorizing our resources a bit here. So a renewable resource is any resource that can be replaced about as fast as we can get it. Um, Now, the way we're going to apply this here is having to do with like how we get our energy from power plants or something like that. So when we talk about renewable resources in that regard, it refers to ways we can get our energy that we can very quickly replace it and not it doesn't take a long time to recover whatever we just used up. So like wind, for example. The reason wind power is a renewable resource is because there's going to be more wind coming around to turn that windmill that's going. The reason solar power is renewable is because the sun is going to continue to shine down. Um, this is in contrast to what we call a non-renewable resource. So something that as we use it, we cannot actually replenish it as fast as we use it. So a good example of this would be coal. We burn coal in power plants, and we actually don't mine it as fast as we use it up. So inevitably there's going to be some point where we run out of coal. Um, Oil is another one. We use up oil faster than we can replace it. Natural gas, aluminum, gold, platinum, all that stuff we mine out of the earth, that's a non-renewable resource. Now you see this word fossil fuel here, and we use fossil fuels a lot to power um, different things in our lives. Um, like the lights above me right now are fueled probably by, well, that's nuclear power around here. But lots of places they use coal power plants, they burn coal. In my car, I use gas. Now, these are all derived from um, dead, decayed organisms from a long, long time ago. Basically, all the oil that we use, for example, is plankton that died millions and millions and millions of years ago, sunk to the bottom of the ocean, had lots of rock piled over it, so it crushed it and liquefied it into this crude oil that we then refine. Um, and that's what fossil fuel is. That's one example anyway. We'll talk more about different examples of fossil fuels in class. One misconception, people think that a lot of our fossil fuels are made up of dinosaurs because there's a famous gas company that has a dinosaur as their logo. This isn't really the case. Um, don't get me wrong, it's possible that a vehicle you've driven in has burned up a few carbon molecules that may have at one point been part of a dinosaur, but the vast majority of our oil actually comes from dead plant and algae matter. But anyway, as far as non-renewable resources go, um, when you start using up 90% of the resource, or when you've used up 90% of the resource that is on Earth, so only like 10% of it is left, we call that resource exhausted. For example, when there gets to be a point where there's only 10% of all the oil that has ever been on Earth remaining, that is, first of all, that's going to be a bad situation if we're still dependent on oil. But that is when it's exhausted. It just is not feasible to keep using that resource because if you stay dependent on it, you're going to run out, and then you're kind of in a bad position. So here are some common minerals that we mine, and the vast majority of these are non-renewable. So limonite, magnite, hematite, we mine those to make iron. We mine galena for lead. Quartz is a famous one. We mine that to make glass, electronics, different lenses. Feldspar is very popular in ceramics, and I think there's feldspar in marble. Talc, if you guys have seen LeBron James do this whole thing, that's talcum powder that he uses. Talcum powder is used in a lot of stuff for health and whatnot. And fluorite is a mineral that's used in toothpaste and in our water supply. And I think, hopefully I'm not mistaken, fluorite is our Illinois state mineral. How exciting. So there is a concept called the production cycle. Well, the production cycle is really a graph, and it shows the rate at which a resource is mined and used over time. So you see at the bottom, you have time. And this is an example of an oil production cycle down here. You see on the y-axis is oil use. At the very beginning, this is of the graph was a long, long time ago. That was back when we didn't really use oil very much because we were just starting to mine it. So you don't use up that resource very much very early on. But as you start to discover a resource and mine it more and more, or in the case of oil, drill it more and more, it starts to get used more. So the use goes way up. But then over time, we get to a point where you're not taking the resource, you're not mining the resource as fast as you're using it. Therefore, this actually pushes demand down, and the use for that resource sort of levels out and then starts to go down to the point where you're not taking very much out, so less people use it because it's not very available, at which point it levels off. So a lot of people believe we're actually like right here as far as oil goes, where we are at the prime of oil use, but soon our little production curve is going to go down because we're going to stop taking oil out as fast as a rate. We're not going to be as dependent on oil. And that is it. So hope you enjoyed and have a good day. Next time, Mr. Harkins, Mr. Black will be back.